I'll introduce a very effective way of factorization of quadratic expressions. For example, if we have a quadratic expression, x squared plus 8x plus 12. So we want to factorize this expression into a multiplication of two terms. Okay. So here, what do we do? If the coefficient of the x squared is 1, so we only need to figure out how to factorize the constant term first. For example, 12 can be factorized as 1 multiplied by 12. It also can be factorized as 3 multiplied by 4 or 2 multiplied by 6. And then we check whether the summation of these two factors is equal to the coefficient of x. So in this example, we check whether 1 plus 12 equals 8. Definitely not. We check whether 3 plus 4 equals 8. Definitely not. And then we check 2 plus 6 whether equals 8. Yes. So in that case, this quadratic expression can be factorized as x plus 2, x plus 6. And you can verify this as correct. Okay. Probably I can show you another example. So another example is x squared minus x minus 6. And then we look at the constant term. So minus 6 can be factorized as minus 1 multiplied by 6. Also can be minus as probably 6 minus 6 multiplied by 1, or minus 2 multiplied by 3, or minus 3 multiplied by 2. I think that's all. And then you do the summation and the check. You summate, you sum these two factors, and you check whether the result is equal to the coefficient of the x. Okay, so we have minus 1 plus 6, which is 5. Definitely it's not minus 1. We got minus 6 plus 1, which is minus 5. Doesn't equal minus 1. We got minus 2 plus 3, which is 1. Doesn't equal minus 1. And then we got minus 3 plus 2, which is minus 1. So that's the answer we are looking for. So we can factorize this quadratic expression as x minus 3 multiplied by x plus 2. And you can check this is correct. Okay, all good. But what if the coefficient of x squared is not 1? In that case, we can have a different way. Actually, that's the main thing I want to share with everyone. For example, we have a quadratic expression 3x squared minus 7x plus 4. So what do? We try first, probably we focus on the coefficient of x squared and the constant term, and we do the factorization of these two numbers, 3 and 4 in this case. So in this case, we factorize 3 as 1 multiplied by 3, and we write these two factors vertically like this, 1 and 3. And then we factorize 4 as well, and we write its two factors vertically again. So in this case, we write that into -1 multiplied by -4, and then we want to check something. The thing we want to check is we check the summation result of the cross multiplication. Okay, so probably I should say in this way. First, we do the cross multiplication. So we say the cross multiplication, and then we sum the result of the cross multiplication. So what do? We do 1 multiplied by -4, and then this is added to 3 multiplied by -1. And we want to check whether this result is equal to the coefficient of x. So here we want to check whether this is -7. And obviously it is equal to -7. So in that case, this quadratic expression can be factorized as x minus 1 multiplied by 3x minus 4. So basically you see here, this column, this column, the following column, will be used as the coefficient of x. And this column will be used as the constant part. So corresponds to this positions, okay? So you may think, how do you work out this in this way? You may, in fact, you may have to try a few times. For example, you may multiply 3, you may factorize 3 as 1, 3, and then for 4, you may factorize that as 2, and then you do the cross multiplication and sum them up, and you got 2 plus 6, which doesn't equal -7. So you probably have to try a few times until you get something here. All right, I'll show you another example of doing this. So here we have, let's just draw a line here. We have a quadratic expression, 10 times x squared minus 7x minus 12. How do we factorize this quadratic expression? Again, we try to factorize the coefficient of x squared and the constant term in this quadratic expression. So here I'll factorize 10 into 2, 5, and then I'll factorize minus 12 into -3 by 4, and then I'll do the cross multiplication and sum them up. What I get 2 by 4 multiplied by 4 plus 5 multiplied by -3, which is definitely -7. And then I'll use the first column as the coefficient of the x, okay? I'll factorize the original quadratic expression into 2x minus 3 multiplied by 5x plus 4, and you can check this is equal to the original quadratic expression. So probably if we look at the this example, you will see when the coefficient of x squared is 1, actually we can do it in the same way as we do here for the following two examples. We still, for example here, x squared plus 8x plus 12, because the coefficient of x squared is 1, so we factorize that as 1 by 1. And then we factorize this term, constant term, to 2 multiplied by 6, and then we still do the cross multiplication, and then we sum them up. We got 1 multiplied by 2 plus 1 multiplied by 6, and we got 6. And then the first column will use the 4 coefficients of x. So we got x plus 2 multiplied by x plus 6. Now, obviously, you see we have a unified approach to do the factorization of quadratic expressions. Okay? Thank you.